Now let's see another problem regarding the matrix inverse, right? So here our question is the proof that if A is the order 3 by 3 matrix given here, so then A inverse will be this. So as we know that the about the matrix inversion, that A inverse, which is equal to the adjoint of A divided by the determinant of A, right? So at the previous lecture, we have learned about the matrix inversion, right? So if our determinant of A, if our determinant of A, this portion, this denominator portion, right, is not equal to 0, so then that matrix become a non-singular matrix. And for non-singular matrix, the matrix inverse exists, right? And when the determinant of A, when determinant of A is equal to 0, so then what will be happen here? So here the denominator part will be 0, so adjoint of A is divided by 0, so that will be here A inverse will be here what? Undefined, right? So at the first, here we have I just written the given matrix A is equal to a 3 by 3 order matrix. So we need to prove that just A inverse will be this minus 1 by 50 times this matrix, right? So let's see. At the first, I have taken here the determinant of A. So determinant of A expanding along with the first row. So we have minus 50, right? Here minus 50. So minus 50, which is not equal to 0. So obviously is the non-singular matrix, right? So its inverse exists. So now just take here the cofactors of matrix A. So for the row 1, C11 first cofactor, just deleting the first row and the first column value, we have the lower determinant, this determinant, right? As we know that the cofactors of the element of matrix A is the minor of element with a prescribed sign, right? So here we just written here minus 1 to the power first row plus first column with this determinant, this minor, right? So minus 1 square, which is become plus here, right? So expanding it, we have minus 4, right? And for C12, just deleting the first row and the second column, we have this determinant, right? And at the first we written here the prescribed sign minus 1 to the power, just notice here minus 1 to the power first row plus second column, right? So minus 1 cube will be minus here, right? So by expanding it, we have 14. And for C13, and C13 is will be same. So for the C13, just deleting the first row and the third column here, first row and the third column, we have this part of determinant. So here just at the first right here the prescribed sign, that is the minus 1 to the power first row and the third column with is minor 3 1 minus 1 0, right? So which is equal to 1. And for row 2 the process will be same, and for row 3 also the process will be same. And now the matrix of cofactors of A, right? So the cofactors matrix of cofactors of our original matrix will be just put here. For the first row here the value is minus 4 14 and 1, okay. And for the second row put this value minus 12 minus 8 3, okay. And for the third row just put this value 6 4 and 11, right? And adjoint of A will be the transpose of the matrix of cofactor, right? So just here that just transform the first row into the first column into first row, second column into second row and third column into third row, right? So now just put the uh, formula here. A inverse which is equal to what? Adjoint of A divided by the determinant of A, right? So our determinant of A, value of the determinant of A was the minus 50, right? So here will be minus 1 by 50 and adjoint of A. So adjoint of A, this matrix. So put just this matrix here. Okay. So hence proved our question here. So right. So do not forget like and subscribe my channel.